Yeah. So pod is a smallest building block that we can run in the Kubernetes cluster. So we are using kubectl to send a request to the control plane to create a prod. API server will receive our request and will store request details in the etcd. Scheduler will find unscheduled pods and it will schedule in the worker nodes. Node agent kubelet will see pod schedule and it will fire Docker engine. Docker will Docker engine will run our containers. Pods are ephemeral, short-lived objects. Right, guys? So manually created pod is not recommended. So what we followed, guys, we followed about the replication controller and replication set. So on daemon set, daemon set is nothing but a the redundant, guys. So daemon set is nothing but a so replication controller and replica set. So what is the replication controller and what is the replica set, guys? So, so the deployment, the manifest file is the deployment file. What is the file, guys? So, so before we see the manifest files before. So before we see the manifest file, something like a first file, something like a pod data manifest manifest files manifest aml files. Guys, tell me what is the first manifest file we wrote pod data yaml. So for example, this is for a pod for creating the pod. Then yeah, guys, service data yaml for service we so pod so pod will not expose directly will not expose outside directly. So will not expose the outside directly. Will not expose the pod directly outside. So which one we need a so how you can expose the directory? So pod himself as a it will it will communicate internally. That is nothing but internally. So within the cluster it will communicate. It will communicate. So it will communicate. Why, guys? So why it is communicate? Pod ml will not expose outside directly. So within the cluster, so it will communicate. It within the cluster, it will communicate. And pods are short. Pods are short short-lived object. So pods are short-lived object. Short-lived object means so if if the pod is deleted, if the pod is deleted, it automatically, guys, it automatically change the IP address of the server. So for example, so if you took the pod IP address to expose our application, the pod delete it automatically created another pod and the IP address also change. So that time is your application working fine or not right, guys? So so that is the reason. So that is the reason pod will not expose outside. Pod will not expose outside directly, and pod is pods are the short-lived objects. So that's the reason we need a Kubernetes services. What is that, guys? Kubernetes services. Kubernetes services. So what are the Kubernetes services, guys? So what are the Kubernetes services? Guys, tell me. What is the first one? Guys, what is the first one? Kubernetes services. Cluster, cluster port. The first one is the cluster port. Second one is the, guys, tell me, guys. Speak out.
Load balancer.
Yeah, load balancer. So load balancer. So the third one is, so what is the third one, guys? Third one is elastic. What is that? Yeah, yes, correct.
Node port.
Yeah, who is?
Node port.
Yes. So load balancer. So load balancer, Kubernetes services. So why these services? To expose the pod outside of the cluster. To expose the pod outside of the cluster. So what is this, guys? Guys, listen carefully. Okay. So listen carefully. For example, this is the example. Is the example, guys. What is this? So this is the example. This is the example, guys. So what is this? So Kubernetes services. Kubernetes services cluster port. Yeah. So cluster port, load balancer, node port. So the service YAML. Why the service YAML? Service YAML is for to expose the pods inside and outside. What is the service YAML file, guys?
To export the
To expose the to expose the pod to expose the pods inside and outside
right.
of the cluster.
Uh,
Inside and outside of the cluster. Inside and outside of the cluster. You see, guys, this is a cluster IP, cluster port. What is this, guys? This is the cluster port. So this is the cluster port. So cluster port is nothing but what is that, guys? Within the cluster, it will expose. So within the cluster, it will expose. So within the cluster, it will expose. So within the cluster means, so we need a communication between the backend and the database apps, guys. So database and backend apps. So we need a, so we need to communicate with each other. So this is the within the cluster. So EKS cluster. What is the EKS cluster, guys? This is your EKS cluster, control plane, worker nodes. For example, this is one of the worker node. In the worker node, so front end apps, back end apps, database apps are there. So we want to expose from outside of this is the end user. This is the front end. The front end is nothing but a Facebook app. So if it's Facebook app, we need to expose outside, right? Everyone can access this. So this is nothing but a outside. So www.facebook.com. So this is the outside, right? We need a outside access. So what is that, guys? So we need a outside access. For outside access, we need a for so outside for exposing. So so outside, both are outside cluster will expose the parts. Will expose the parts. Guys, understood? So very important, guys. So that's the reason I'm telling again. So you guys are understood. So these both are these both are outside of the cluster will expose the pods. So load balancer, node port. So and the cluster IP. Cluster IP within the cluster it will expose. Within the cluster it expose. Load balancer notepad outside the cluster also will expose the pods. So this is nothing but a service YAML file. So this is nothing but a service YAML file. So if you want to run if you want to run a pod in the Kubernetes cluster, so we need two YAML files. We need a two YAML files. What are those? Guys, tell me what are those? So one is pod YAML file. Sorry, guys. So one is pod YAML file. The other one is service YAML file. So pod YAML file and the a service YAML file. So we need a pod and a service YAML files. Guys, understood? So we need a pod YAML file and the service YAML of file. This is the a pod YAML file and this is a service YAML file. Guys, so this is the what this is, guys. This is a manifest file. Manifest file. Manifest YAML of file. So in the pod, so it will the pod. So what is the manifest file, guys? The starting is the manifest file. Yeah. So how you can start? You can start three hyphens and what is this, guys? API version. Yeah, guys. Four you need to remember, guys. Kind, kind. Guys, tell me. Metadata and spec. Spec is nothing but a specifications. This is our this is our YAML file. This is our manifest YAML file. Everywhere we need to provide the API version, kind, metadata, spec. Kind is nothing but a pod. Kind is nothing but a service. Kind is nothing but a yeah cluster port or node port. Right, guys. So client is nothing but a service. In the service, we need to provide the cluster port or a load balancer or a node port. Guys, understood? Speak out, guys. Speak out, guys. Speak out. This is the manifest file. If you remember this, it will be easy to write the manifest files. It will be easy to write the manifest files. Guys, understood? Guys, speak out, guys. Understood or not? Ani, Fanindra,
Yes, sir.
Lavanya. Right. So we discussed the pod, we discussed the cluster services. So cluster services are the services, Kubernetes services are the cluster port, load balancer, and node port. These right, simple, easy, 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 easy. Kubernetes is very easy. Okay. Is it easy or not, guys? Yeah. So this is a pod service YAML. So in here in this YAML manifest YAML, if pod deletes, it will recreate or it will not recreate. It will not recreate. Oh yeah, it will not recreate. So what is the Kubernetes control plane? Kubernetes advantages auto healing. What is that, guys? Auto healing. What is a auto healing? Auto healing is nothing but it automatically, if pod is deleted, it automatically create the new pod. That is nothing but a auto healing concept. Auto healing and auto scaling also. What is that, guys? Auto healing and auto scaling. So what is auto scaling, guys? Auto scaling means, guys. So what is auto scaling? Guys, tell me what is auto scaling? Scale
We can
down.
automatically update the workload.
scale down and scale up. So for example, I want a scale up the pods. I want to scale down the pods. So we can use the scale up and scale down. This is nothing but a auto scaling. Auto healing is nothing but if the pods are deleted, it automatically, if the pod is damaged, crashed, anything, so it will create the pod, right? It will create the pod. How you can achieve these things? So are we achieving these two things in this manifest file, guys? No, it is not. It is not achieving the it is not achieving. We are not achieving the auto scaling and auto healing concepts in the manifest file, pod and service manifest file. Yeah. So what is the Kubernetes advantage? Auto healing and auto scaling. So how we can achieve auto healing? Auto healing purpose for auto healing purpose. So auto healing. What is that, guys? Auto healing. So auto healing is nothing but a, so if the parts parts damaged or crashed or deleted. So cat deleted, it will automatically create it. So how we can achieve these things? We can achieve these things by using Kubernetes components. Replication controller. What is that, guys? So replication controller and replica set. Both are same. Both are same. But the replication controller and replication set. So it will provide the replicas. In the manifest file, it will provide the replicas. Replicas, something like a 3 replicas, 4 replicas. So it will provide the replicas. It will provide the replicas for the both. So means at any cost, only 3 pods will running at every time. If one pod is crashes, automatically create the pod. So this is nothing but a replication controller and replica set. So replication controller is the older one. Replica set is the newer one, next generation. So what is the difference between replication controller and replica set? So the replication controller and replica set is nothing but a, so there is a difference between replica set and replication controller. So what is the difference between replica set and replication controller, guys? This is the last class. So what is the difference? So replication control supports replication RPC controls. So RPC replication control supports equality based selector. So what is that, guys? So equality based selector means we can set only one selector, but in the R replication replica set RPS, it supports set based selectors. So means set based selectors. So set based selectors, we can select something like so we can select VS Code, right? Match label. What is it, guys? So match label. So this is nothing but a deployment file. Yeah, here. The selector. So what is that, guys? Match label. It supports. What it supports? It supports the match label. So match label, and we can select app version. So we can select same like this, guys. So we can select like this. Match labels. It select app select it select app, it select app and version, multiple labels it will select set based. So equality means only one selector, but replication control it will select multiple selectors. Multiple selectors is nothing but a match labels. So match labels. So this is nothing but a auto healing, right? Auto scaling. Auto scaling, how we can achieve auto scaling? By using the deployment. Yeah, here replication controller and replication set, right? The other one is daemon set. What is that, guys? The other one is a what is that, guys? Guys, tell me what is that? Daemon
Dimension set.
daemon set. What is a daemon set? Guys, tell me. So I will show you once. Yeah, the difference between replication control and replica set. So it is a equality based selector. This is a set based selector. So here selector match labels app version type, right? So what is that, guys? A daemon set. What is that, guys? Daemon set. A daemon set ensures that all the nodes run a copy of the pods. As nodes are added to the cluster, pods are added to them. As nodes are removed from the cluster, those pods are garbage collected. Deleting a daemon set will clean up the pods. So we'll clean up the daemon sets. Daemon sets ensures that all nodes run a copy of the pod. As the nodes are added to the cluster, pods are added to them. As nodes are removed from the cluster, those pods are garbage collected. So means daemon daemon set. So daemon set means so for example, so here we have a two worker nodes. So two worker nodes. So if you create the pod in the worker node, one worker node, the second worker node also it automatically creates. It's a duplication mirror. What is that, guys? It's a duplication or a mirror. So daemon set. So this is nothing but a daemon set, guys. So this is nothing but a daemon set. Next, how we can achieve the auto healing? By using deployment. What is that, guys? By using a deployment. So deployment. So what is the kind, guys? Kind is a deployment here. So kind is a pod, kind is a service, kind is a replication controller, kind is a replica set, kind is a daemon set. Now kind is a deployment. Now kind is a deployment. Guys, now you understood? Kind is a deployment. In the deployment file, so deployment is one of the Kubernetes resource and components. Deployment is the most recommended approach to deploy our application in Kubernetes cluster. So what is the most recommended approach to deploy our application in Kubernetes cluster? What is that, guys? Deployment manifest file. So what is the most recommended deployment is the most recommended approach to deploy our application in the Kubernetes file, Kubernetes components, guys. In the real time. So in the real time, which one is using to deploy our pods? By using the deployment manifest file. What is that, guys? Deployment manifest file. Yeah. So this is the so what we learn, guys, till now we learn these things. And so deployment, so we use the deployment and the so using deployment we can scale up and scale down our parts. So we can use scale up and scale down. Auto scaling is nothing but a scale up and scale down our parts. Deployment supports rollout and rollbacks. So to deploy latest code, we have a delete. We have to delete RC, RS, then pods will be deleted and application will be also down. right? So we can deploy latest code with zero downtime using the deployment. You can using the deployment, zero time, rollout, rollback, and auto scaling. Rollout, rollback, and auto scaling. Auto zero downtime if you use the deployment manifest file kind. So zero downtime, rollout and rollback, auto scaling. So these are the key features in the deployment component. Deployment component. Guys, understood? Is it easy or not, guys? Guys, easy or not?
Yes, bro.
This is the Kubernetes. Kubernetes is very easy, guys. Kubernetes is very easy if you learn. If you learn, Kubernetes is very easy. Guys, you understood? So the pod, service, auto healing, auto scaling, cluster port, load balancer port, node port, auto healing, auto scaling. So replication controller, replica set, right? Daemon set. It's a very, very easy, guys. Okay, understood? Very
Yes, bro.
good. Yes. So now, so these all are the deployments. These all are the deployments. Next, deployment strategies, guys. What is that? Deployment strategies. So what are the deployment strategies, guys? So what are the deployment strategies? So yesterday we deployed, right? We deployed a new parts. We deployed a new version image. So how it will be? How it will be creating? What is that, guys? How it will be creating deployment strategies? Guys, tell me. Deployment strategies. So what are the deployment strategies, guys? Deployment
Yeah.
strategies. So what is the deployment strategies? Guys, tell me. What are the deployment strategies?
Rolling the deployment.
Very good. Very good, funny. This is most important, guys. One is rolling,
Rolling deployment. Deployment.
rolling update. The second one is, what is the second one, guys? Rolling update means, so we
Ongoing.
have, yeah, we have a two parts. We have a, for example, three parts. Three parts. The first part will crash. It will delete and create another part. So one by one, recreate is nothing but a one by a one. So one by one, it will update.
Means
Oh,
which we
sorry,
can
rolling update.
recreate, which we can replace the existing part with the new ones, right?
Yes, yes, yes. Recreate. What is that, guys? So deployment strategies are. What are the deployment strategies, guys? Deployment strategies are rolling update, recreate. This is a Kubernetes, guys. Is it very simple or not? The entire Kubernetes is here only. Is it easy or not, guys? Guys, please practice, guys. Please practice. Then only you will understand. Then only you will understood. Guys, this is the class we discussed in the Kubernetes. Very easy, guys. Very easy. Very, very easy. Right. So what are the deployment strategies? So deployment strategies are, we have the, so we have below deployment strategies, a recreate and a rolling update. What are the deployment strategies, guys? Recreate and a rolling update. So recreate means it will delete all the existing pods and it will create a new pods. Downtime will be there. Downtime will be there. A rolling update strategy means it will delete the pods or create a new pod one by one. What is that, guys? It will create a rolling update strategy means it will delete the pods and create new pod one by one. So one pod it will delete, it will create another pod, it will new pod, another pod, old pod is delete, it will create, old pod is delete, it will create. This is the rolling update. So what is this, guys? This is a recreate. What this is, guys? This is a recreate. Recreate means all pods will delete at a time. All the pods will delete at a time, and all the pods will create at a time. That is nothing but a recreate. Here, downtime will be there. Here, downtime will be there. Here, there is no downtime. Here, there is no downtime. Guys, got it? All Kubernetes commands, kubectl get pods, get svc, delete all, pod apply deployment, get pods, get svc, get deployment, delete deployment. Strategy recreate. So recreate means, so the deployment file strategy is recreate. So we have a two parts. It will create, it will delete all the two parts and it will create the new parts. If we use the strategy recreate, it will delete the parts and create the parts. So what are we previous parts available? Those are delete and will recreate the parts based on the replicas. So recreate means existing parts will be deleted and new parts will be created. Application will don't have a downtime or will have a downtime in the recreate. So definitely there will be a downtime because of, so we are deleting entire, right? At a time we are deleting entire, then it will recreate. It will recreate. That time definitely there will be a downtime for the application, right, guys? Yeah. So recreate strategy. So all the existing parts are killed before a new parts are created when the recreate deployment strategy. So rolling update. So rolling update, it will delete one by one pod and create one by one pod. Yeah, guys. So those two are the strategies. So this is a deployment model. So what is that, guys? Blue and green deployment model. So DevOps, most of the DevOps are using blue and green deployment model. What is blue and green deployment model? So black, white deployment, red block deployments, these all are the strategies only. Kubernetes does not have any relation with this deployment. Any relation with this Kubernetes. It's a model. It's not a strategy. It's a model. Kubernetes does not have any relation with these deployments. Mod. So our own purpose we are creating blue and green deployments. This is just a generic approach to deploy our application in the production. What is this, guys? This is just a generic approach to deploy our application in the production. So what is blue and green deployment? Blue and green deployment is an application release model. What is this, guys? Application release model. Yesterday we saw, right, how the applications are released. So this is a deployment is an application release model. It reduces the risk and minimizes the downtime. It reduces the risk and minimizes the downtime. It uses two production environments known as blue and green. It uses two production environments, known as blue and green. The old version can be called as a blue environment. The new version can be known as a green environment. Advantages with the blue and green model. What is the advantage of the blue and green model? Rapid releasing, simple rollbacks, built-in disaster recovery, seamless customer experience, zero downtime. What are the advantages, guys? Rapid releasing, simple rollbacks, built-in disaster recovery, seamless customer experience, zero downtime. So this is our application. So we are checking in the web, guys. This is the internet, your application. So your application will be available in the two environments. One is blue environment, the other one is green environment. Old connections are maintained in the blue environment. Green container, new code, the new connections go to the new container. Oh, blue and blue containers. Yeah, here we have a two environments, guys. For example, Facebook is deployed in this environment and this environment also. but the end user is the router, the writer, right? The switch. Yesterday I already told you, right, guys, that DR and primary and DR. DR is nothing but a disaster recovery. For example, if something goes wrong on this here, it will it will route to the it will route to the disaster. It will route to the DR environment. The same way here also, it's like blue and green environment. Blue and green environments. The shared resources, for example, database services, everything will be pointed to the one service only. But the application is created two types. That there is the app servers and services, app servers and services. This is the blue environment and green environment. Now the end user is pointing to the blue environment. The end user is pointed to the blue environment. For example, you're using a V1 and V2. The blue is live. End user is using blue environment. Blue environment. The new release, something like the new release is deployed on the green environment because of so the router because of the router guys because of the router router is pointed to the blue environment only because of the router is pointing to the blue environment only. But the new release, whatever the developer develop that code, right, and developer that code, write it and deploy it in the green environment, and the tester will test the this environment. Once it is successed, so once it is successed, so the new code will be available in the green environment, right? That status code. For example, this is the WhatsApp. WhatsApp contains only chat and contacts, but developers created a other feature called as a developer other feature called as a status here. The status is deployed in the grid environment, but the end users are not using this. Still the end users are using the blue environment, blue environment, right? So once it is successed, the router will be live on the green environment. They are connecting to the green environment. Now the end users is routing to the green environment. So green environment. Guys, understood? Guys, understood or not? So the practicals, for example, end user. So this is the label one. This is the deployment version one, a deployment. This is the blue plot. So labels version V1, and this is the type of the load one. This is the live service. So live is now the end user is connecting to the so in connecting to this load balancer. Load balancer means outside of the outside of the AML, right? So this is the, for example, service. This is the service of the. So if you want to point to this, or if you want to point to this, so load balancer for outsiding exposes purpose. So something like the green deployment is pods are live, and I want to select as a this load balancer, this live service as a this is a pre-prod service. Pre-prod service will be tested by the testing team. Once tested the testing team, so we need to live this green pods. So here the version, right? If you replace the version from V1 to V2, it automatically point to the green. The router is point to the green. Guys, understood? This is the deployment model, blue and green model. So blue and green deployment model. For example, blue deployment model, we have a AML file, live deployment services, the service pod, and green deployment model, and pre-pod service. So we'll create the four AML files, and so the deployment procedure. How we will proceed the deployment. So deployment procedure is create a blue deployment YAML file, then expose the pods to the using live service, access application using the live service, blue pods will run, modify a code in the Git repo, clone the latest repo, build the project using Maven, create a Docker image, push image, create a green deployment, expose the green pods using the um, pre-prod service, application access application using the pre-prod service. So pre-prod a service. Guys, config marks and secrets. These are the most important. We'll discuss We'll discuss later because of we need the secrets, right? So the deployment database file are the files having the username and password. So we want to config map. So every application, multiple environments will be available for the testing purpose. DevOps, UAT pilot. So one application testing is completed in all the above environments. Then it will be deployed into the production environment, live environment. For every environment, application properties will be different. For example, database properties, stock, Kafka properties, FMT properties. So we need to hard code these properties. How we can hard code these properties? By using config map and secret. By using config maps and secrets. So we'll discuss tomorrow, guys. So tomorrow we'll discuss this deployment procedure also. I will show you how to do it. This just create a deployment file service v1 v2 and we will add it, guys. So we will add it and we will show it what is green deployment practical. Okay, so config max and security. For every application, multiple environments will be available for testing purpose. DevOps set to UAT pilot. So once an application testing is completed in all the environments, then it will be deployed into the production environment, live environment. For NV environment, application properties will be different. So database properties, Kafka properties, and SMTP properties. We need to hard coded these properties. So we can keep it in one file, and we need to use that. You need to use for every environment, right? Okay, guys.
So, bro,
Mm,
can you share these documents in the drive link?
I will.
And one more thing, bro. Yesterday
Mm.
you done some deployments. Can you provide the steps in document form? Possible.